So, hello everyone. My name's Dr. Miles Stopher. I'm the Director of Admissions in the Department of Engineering and a researcher in nuclear engineering.
Okay, my name's Maria Kettle and I'm the Outreach Officer at the Department of Engineering. So I have a hand in organising all the stuff like open days and this thing. And what we're about to do is a guided version of the 360-degree tour of the Department of Engineering. So we've got a long drive where our engineering is sort of hidden behind buildings, and this is the front entrance. So I'm about to head you up our main staircase and haven't shown you reception at all, but there's a version of this tour available and you can take yourself around this tour and linger and look at everything, and there are videos and things inset in it, so go have a look at that. First thing we're going to show you is this one. This is one of our lecture theatres. So this is lecture theatre 5, relatively recently refurbished, so it's full of fancy kit for presentations. Yep. Okay, so this is quite a small lecture theatre. We have some much bigger ones, but they've got building work going on in the moment, so you can explore those on the 360 tour. We're showing off the nice ones, let's be honest about it. This is our library, and you have to do this. There are bits of this tour that just land you in the wrong direction and they're not having any of it.
It immediately wants you to leave the library.
Fix them. So that was the exit. This is the entrance to the library. It's sort of a long, thin corridor. That's actually the emergency exit to the lecture theatre we were just in, and this is the library proper. We have some fab artwork in the department. I really like this one. Is Terence Cuneo did lots of railway art, and that's one of our Terence Cuneos.
So is that the reception desk just behind us? So you'll spend quite a lot of time in here. Obviously all the colleges have their own libraries as well, but the engineering has quite a large library for you to come and do private study or group study. Like you can see there, we've got a silence space for those that want a bit of peace and tranquility when they're doing their work. And then here is where you can do some group work. So we've got some communal seating areas around there for you to do some of the interesting project work that you get to do.
They call this the collaborative space, and things like those computer screens there, you can borrow a lead. If you're working with some colleagues, want to share a laptop, the library desk will issue you with a lead and you can plug your laptop into a big screen and share what you're doing on a big screen. Miles, over to you.
Yeah, so if there's ever some textbooks or anything that you need, then there's always someone on the desk at the library that can give you a hand. If the book is not available, then they will get it for you, so it will be available relatively soon. Where we're coming into now, we should probably speak a bit quieter, into the silent space. So this is where you go when you're perhaps doing some private revision. So you have your collaborative space where you want to be a bit more teamworky. So again, a similar sort of thing, places to put your laptops, endless textbooks for you to take advantage of for the plethora of worksheets that are going to be offered to you during your time here. And then we can exit. So a nice little feature of Cambridge Engineering is where we are here, the Language Resource Centre. So as part of your time at Cambridge, you can learn a language. So we have all the support that you would need to do that. And a lot of students choose to do that as an aspect of their course. So this is what we're looking at now. So there's a lot of communal and teaching spaces to take advantage of when you're getting your language lessons.
So there's lots of videos and textbooks, and then the language, they teach 5 languages, so French, German, Spanish, Mandarin Chinese and Japanese, and so there's regular language learning resources there, but also the emphasis is they teach language with an engineering bias. So I did a beginner's Japanese course, and we were doing kids maths addition, but maths in Japanese from the get-go, and yeah, it was not challenging arithmetic, but in Japanese. And so there'll be lots of magazines and things, and engineering professional publications in your target language lurking on those bookshelves.
I mean, yeah, they always say maths is supposed to be a language on its own, so everyone who's an engineer can speak math. But until you try and do math in a foreign language, you quickly realize it's not as straightforward as it first seemed.
Right, I'm doing a lightning whiz back through the library, and you might lose the commentary on this one because through the library we are heading for the Dyson Centre. I've got to pick my route here. Okay, so this is the bridge that takes you into the Dyson Centre, and the Dyson Centre is a make space. So if you have a bright idea and you want to make something, there's the best toolbox you'll ever have to make things with. So this side of the Dyson Centre, which is the south end, is quite traditional engineering. So that's the technician desk, so lots of help there. But workbench along this side used for the first year structural design project, and that's an example of a bridge on show there. Round here we've got, we've zipped past the boat, I'll linger on that later. This is into mills and lathes, and you have to, there's formally, you sign up for a session and you learn how to use these machines, because they are real machines, they're not toys. I think there are 3 mills and 2 lathes, and they are serious engineering kit. But about 5 groups of people a week are training up to use these every week. So hundreds of our students by the end of the year are confident users of these machines, and what you can make with them is amazing.
Yeah, it's outstanding. I mean, I remember the first time I came to see this, having all this array of machines for you to just do, honestly, really whatever you want, is an incredibly rare thing.
This is where they make robots on this side of the lab, so it's opposite to where we saw the structural design project earlier. And actually, there we go. Look, that is full blue racing car.
Yeah, so it's society. It's a society that you can all get involved with if you fancy a little bit of racing. So you can construct the race car yourself and race against other university teams.
Yep, and there is a very well-beaten path between Cambridge Engineering and Formula One. I take you here, there we go, boat, as advertised. That's actually the second boat this person has made. Yeah, so he's a sailor, makes boats. And actually, how do you get it out of here? Between here and the racing car, there's actually a great big hole in the floor, and if you get vertigo like I do, you can scare yourself occasionally by standing on these steel beams that, and just here is a great big crane, so they winch, and if they're getting steel up and down for various things, that's how they do it. So that end of the Dyson Centre is quite traditional engineering. Up this end, Just here, there's sort of meeting spaces, because a lot of what goes on is student teams, it's collaborative, so lots of spaces to hold meetings. And we come to this end, and it's quite a different style of manufacturing. So, Miles, are you going to talk about this one?
Yeah, so you've got quite a few 3D printers, laser cutters, for sort of alternative collaborative work. So that's what you can see there, just on the left, some of the cutters. And then there in front of us are the 3D printers. So people have made all kinds of things. People like to make their own pens. It seems to be there's always someone doing that. We've had people from different societies or different sports teams coming in and making designing and making their own equipment or improvements. So we had some of the professional shooters come in and make some new stocks for their weapons, which is quite impressive. But yeah,
Laser cutters, and the materials that they cut are actually, there's a big display of them up on the wall there, and the department orders and buys laser cuttable materials at cost price, so they can run quite expensive, but they'll order them in at wholesale prices and pass them straight on to students. And I think students don't pay VAT on them, don't hold me to that one, but you can cut plywood as long as it's got the right glue, cardboard, and then there's lots and lots of acrylic there. And I was going to make a case for my computer out of disco glitter acrylic, laser cut acrylic, and then I worked out it would cost 45 quid and didn't make it. But so it's not cheap, but the plywood, I did make it in plywood, and that cost not very much money at all.
I mean, every time I go in there, a student will be making something that I think, oh, I'd quite like that. I might book in and make my own. So if you ever have, trouble, I really fancy using the Dyson Centre this week, go and have a little walk through, and I'm sure you'll get ideas. It's amazing what students can come up with in this place.
One of the things we're going to show you later on is the robot project that our second year students do. We've got some robot videos, and the amount of robot components are either 3D printed or laser cut, or combinations of the two, is massive. On the left here, this gadget here is a plasma cutter, so very similar to the laser cutter, but for metal, and goes through really quite thick chunks of metal, so again, useful. This here is actually a wind tunnel. The Department of Engineering had a spare wind tunnel knocking about in its attic, as you do. So it wasn't being used, so it's down here, and it's a bookable student resource if you want to put things in that wind tunnel. It has this glass bit here is the working throat, so it's actually quite a little baby working throat as these things go. Free access wind tunnel, use it when you need it.
Yeah, you can optimise your bicycle helmet should you be one of the keen cyclists that we've got.
Undoubtedly fit that sort of size of object in there, and then a lot of scale models of things like the racing car that you saw earlier, and just here in the background here, I don't know whether I've got a better view of that one. Try this. No, it's not. It's the other side of a partition there. There is you can see a bit more of it there. A solar powered car. The university puts together a team that the department puts together a team that competes in the Solar Car Challenge. So this is from Darwin to Adelaide, 3,000 kilometres across Australia, entirely under solar power, with solar panels carried on the car. I say the department puts together, it's a student society, they organise themselves. They did organise, somebody gave them £250,000 worth of space grade solar panel, which is what powers their car. So 21 years old, have £250,000 worth of solar panel. Yeah, that's good.
Hmm.
Right, this takes us out of the Dyson Centre and through what gets called the Orange Staircase to we're now in, there are two buildings in engineering on Trumpington Street site. So Baker Building was built in 1953. What you're in here is a 1960s part of the oldest buildings were 1926, I think. And this is Inglis Main Stairs, it's the Inglis building, and we are heading into here, which is the Electrical and Information Teaching Lab. And so electronics, radio, AM radios get built here, they AM, FM, can't remember, but quite traditional really, lots of workbenches, all the little houses that you see take you straight back to the front gate. And where are we here? This is, these are robot tables, and our students, second year students, work in teams of 6 on the integrated design project. And in theory, of that team of 6, there are 2 mechanical engineers, 2 electronic engineers and 2 software engineers. The best and winning teams, everybody mucks in, has a go at everything, because you can't really do the software till you've got the electronics, and you can't do the electronics till you've got the mechanical bits, the moving bits. So everybody mucks in and everybody has a go, and they make great robots and have a really good time. And the teams that are not quite so cohesive, it's a bit war, and they don't. They'll get very fed up with each other.
Yeah, but makes students really realise how important teamwork is. It's a huge part of engineering. So we do our best to encourage you to collaborate and put you through your paces.
So we're going back to the corridor from whence we came, and down the stairs this time, all the way down. Hopefully we can speed this up a bit. And so this is the 1931 corridor, I think. So our site was a field hospital during the First World War, because the old Addenbrooke's Hospital is just across the road. And now, after the war, it became engineering. So this takes you down to the hydraulics lab, so lots of fluids going on in this space, and there are some baby wind tunnels here that are used for student experiments. And if I'm really clever, that's the one. Takes us back where we want to go. The bit behind this partition here is actually a research lab, and not used except for projects for undergraduate teaching. But this way takes you into the structures teaching lab. And this is the concrete lab for experimenting on concrete. There are people who get very excited indeed about concrete.
And aren't worried when they get completely covered in it, which I wouldn't recommend.
No, but this is the structures teaching lab. So we've got some videos to go in here of showing you students' project and getting them tested to destruction, which is what happens to them. Oh, there we go. First year structural design projects.
The remains, at least.
These things, so A-level maths problems where you do lots of work out the forces in the beams of various beams, and this one is these are instrumented up, so you can measure the deflection and you can measure the load, and the stuff that you study in an AS Further Maths Mechanics module is where this stuff turns up. This is engineering. You get to test it for real and make sure that it's hopefully true and our buildings stay up. There
Yeah.
we go.
Okay.
And shoes, we have a load of steel toe cap shoes, and you get lent a pair if you don't own a pair. If you do a lot of concrete work, you might want to buy your own because they're not very expensive at all, but you absolutely do not need them as a first year undergrad. But yeah. Right, so back to the main English corridor, and then we're going to go up the main English stairs here. So this connects a fire escape with the canteen, and actually the robot lab in summer is you can get from the robot lab to the canteen by this route, and it's lovely because it's up in the sky. So
Keep an eye on your peers having lunch in the courtyard, or
yes.
go for lunch yourself, where we're about to take you now.
So this is our canteen, and got recently refurbished and actually quite democratised, because we used to have a senior common room and a junior common room, and never the twain shall meet. But actually, we needed a bigger common room, so taking down the boundary between the two made sense. And oh yeah, this is the headless woman view of the canteen, and so it's really nice. So you know, little tables, big tables, and hot and cold food. And the engineering canteen is famous because it sells all its food at cost price. It doesn't make a profit, it doesn't make a loss. But what it means is that it's a cost-effective place to eat. And so if you want to see somebody, canteen at lunchtime, it's a good place to find them.
Yeah, it's quite a popular place for students to go. There's quite a lot of hustle and bustle there. But like Maria said, I mean, the food is very affordable and it's quite good.
Yeah, it is. It is. Right, this one takes us to the Aero Lab. That's actually a bit of magic. In real life, there's a corridor, but this is our Aero Lab, and what you're looking at here is the outlets of the supersonic tunnels that are behind this partition here. Twirl this one around. Up there, there is a student aircraft competition. So you have to build an autonomous aircraft that is quite a hefty course. It has to fly something like a mile, carrying a payload of about 5 kilos. And it's a model aircraft, but quite challenging requirement. And what you're looking at there is a winning aircraft. That one takes you back to the canteen, or this one takes you back to the front gate. And we are a national wind tunnel research facility. And these are our main wind tunnels.
Yeah, see, I find this was quite exciting for me when I first saw this. I think this sparks a lot of excitement in some of the prospective students. The size of these wind tunnels.
This one here, nearest to us on the image, is the one that was used by Frank Whittle when he developed the jet engine. And this gadget here on top is the balance that he used. So the building that they're housed in now was built in 1963, as he did his work in 1920 something. This wasn't there then, but there were, on this very site, there were a bunch of sheds apparently that were just sort of outhouses with wind tunnels in them, and and then they relocated the wind tunnels. And I think one thing that's not on this tour is our biggest wind tunnel, which is the Markham Wind Tunnel. And that one, they had to build the building around it. It's so big, they built the wind tunnel and then put the building over it. So the only way they can get it out is demolish the building.
Yeah. Now that one I know all too well because that's next to my office. So whenever that starts up, I'm very well aware, because it is quite loud, a wind tunnel of that size. But always is surrounded by excited students who are testing one design or another. And we've had not just aircraft, but we've also had the British GB cycling team, I think, came and did some
Yes.
tests
Yeah.
in there. Yeah.
And we had an undergrad who was the British downhill speed ski champion. And his fourth year project, which is half the marks of your final year, was not make myself go faster, because there's not enough meat in that to be a fourth year Cambridge engineering project. What his project was to make a head-up display so that when he was in the wind tunnel, he could see in real time the live feedback from his project. So he got a lot of wind tunnel testing in and made himself go faster. But there was this other bit of academics. And he was amazing. When he saw his suit, he looked like a manga cartoon. So a great big tapering helmet. And because they squat down and sort of fold up their knees, behind his knees, and on his calf, he had these like calf extensions in his suit, which were big fins that stuck out and looked really odd when he was standing up straight. But as soon as he was squatting, they filled in the space between, sort of underneath his thighs, and made him much more aerodynamic. Who knew? That's what they do on speed skiing. Right, I'm going to find a house here and take us back to the gate, and then we'll go to the mechanics lab. Famous last words, yes. Okay, and then I'll take us out of the mechanics lab and back in from the staircase. And this is actually underneath the lab that you've just seen, but I don't have a connecting link to take us there. But this is the mechanics teaching lab. Got here is these are shakers, and this I think is a model building. Mm-hmm. No, that's a model building. And so they're modelling earthquake damage on buildings, and that's a student project to go measuring that. So this is an experiment of the tread of a bicycle tyre on a road, and I think this thing here is actually an upside down road. So it's a piece of glass with a wheel underneath it, and they run the wheel pressed up against the glass so that you get a kind of worm's eye view of what's going on with the tyre when a thing runs on the road. This big gadget tube here is actually a sound tube, and it has a little door at the end, which I might be able to show you. Can I show you the little door at the end? No, I haven't got the end of the tube. But you open the little door and you click your fingers like that. You're injecting a sound wave into the tube, and just like a glass block will spread the frequency of white light out and you see the rainbow, what this tube does is spread the frequencies of sound waves, so they travel different frequencies at different speeds through the tube. And when you listen, you hear a pitch drop. And once you've ever heard that, you'll never walk through a subway again without giving a big loud clap and trying to hear that pitch drop. And if it's a nice subway that's got kind of quite a regular surface, you can get this, you can hear the frequency drop from the sound. I like things like that. I do.
Yeah.
Things. Right, so there we go. That is the mechanics lab, and I think that's everything we're going to show you. So I'm going to click on a little house and send us back to
the wormhole.
Wormhole through space takes us back to the front gate. And if you want to have your own tour of this, we haven't shown you everything. There's lots of bits we've missed out. So from our web page, it says, click here to take a 360-degree tour around the building. Go ahead, take the tour.